everyone. Welcome to Chem with Dr. M. Today we're going to do a mini experiment called What Melts in the Sun. But before we get into that, we're going to talk about why things melt in the sun. Let's get curious. So every single element on the periodic table has what's called physical properties. Physical properties can be observed or measured that specific identity. So it's not going to change the chemical identity of the substance. It's more like describing the identity of the substance. So what makes us us? We could talk about how we have hair color, we have eye color, we have certain skin tones towards us. That is how we describe our own physical features. But every element has their own physical properties that make that element that specific element. So think of things like, is it shiny? We think of luster. Is it malleable? So could it bend? Each element, some are bendy, some aren't. Is it hard? Is it soft? These are all physical properties. We also want to think of density. We want to think of its boiling point. And lastly, what we're going to talk about today is our melting point. So again, every element on the periodic table has a specific melting point, boiling point, density. That's going to identify that specific element. So what is melting point? Melting point is when you're going to apply heat to a substance, which is going to make it go from its solid phase to its liquid phase. So your physical property is also phase changes. So for melting point, again, we're going from solid phase to liquid phase. Your solids, remember, are densely packed, tiny, tiny, tiny molecules all packed together, squished next to each other. Liquids, you think they're a little more flowy. So again, your melting point is going from your solid to a liquid. Every element has a melting point. Every substance has a melting point. For example, water. We drink water all the time. We're made up of water. Water's melting point is 0 degrees Celsius or 32 degrees Fahrenheit. So what we're going to do today is we're going to take a whole bunch of objects, and everyone could do this at home, and we're going to put it out in the sun and see what's going to melt and what's going to stay in solid form. So you can see here, I found a few things around the house. I put it on a cookie tray. You could also use a cupcake pan if that makes it easier for you. I put some parchment paper on the bottom just for some easy cleanup. All we have to do is bring this outside, leave it outside for about an hour, and we'll see what melts and what doesn't melt. Knowing this, it's about 90 degrees Fahrenheit outside today. So knowing if things melt or don't melt, that they're gonna have a melting point between what's inside, about 70 degrees Fahrenheit, and what's outside, about 90 degrees Fahrenheit. So let's see. So it's been about an hour. I left this outside. You could see that some things have melted, some things haven't. Our ice cube melted, our butter melted, our coin, our penny is still a penny. With the crayon, it looks as if you could see at the bottom, that it was kind of starting to melt. It was getting stuck to the bottom of the plate. So I'm sure if I left it out there a little longer, it would have melted. Our ghost spider stayed in good shape, and our clip stayed in good shape. And our chocolate, let's do a chocolate test. Yes, the chocolate definitely was melty. So the big takeaway for physical properties is that even though some of them melted and some of them stayed the same, its properties remain the same. So our ice cube is still water. It just went from solid form to liquid form. Butter, same thing. Just went from being a solid form of butter to a liquid form of butter. And again, with our chocolate and our crayon, they were definitely on their way to being a little more liquidy. So our phase changes are going to be a physical change or a physical property because of its melting point. Nothing here changed. It is still the same substance that I put in the tray to begin with, but it just went from its solid form to its liquid form, or it remained the same, which doesn't mean it doesn't melt. It just means it wasn't hot enough outside to fully melt. Thank you everyone for following along today. I hope we learned a little bit about physical properties as well as what melting point is, and I look forward to continuing our science journey together. Stay curious.